Ladies and gentlemen, good morning. And my presentation today will be on the effect of urban spatial pattern on the heat vulnerability in the city of Tel Aviv. As we know, the urban climate is characterized by an amplification of air temperature, lowering of air humidity, and moderation of wind velocity. And the amplification of urban air temperature known as the urban heat island, UHI, which defined as the differences between the temperature measured in the city center to those which measured in the rural area in proximity to the city. And the urban population are exposed to an increasing frequency and intensity of weather extreme due to the global climatic change and also due to the climatic change caused by the city climate. And one of the most important implication of the UHI is the increase in heat stress during the day in the summer, which aggravate the human discomfort. Coping with the impact of UHI on heat threats motivate policymakers to find solutions to heat mitigation in order to build climatic resilient cities. So the objective of my presentation is to see what kind of intervention can help Tel Aviv to address the urban warming for its most vulnerable communities, and to develop replaceable method to identify climatically vulnerable neighborhood and public relief space at risk of heat and climate hazard, and to measure and visualize the heat impact to make informed design decision, further monitoring the heat island effect. So, what kind of method, tools, and measurements we have used? So the methodological approach for this study including 4 steps. First of all, we produce a local climatic zone map for the city of Tel Aviv. Then we produce remote sensing monitoring of Tel Aviv urban heat island in order to locate the spatial pattern of the heat island. And finally, we try to assess the human thermal sensation by meteorological measurements. So for the meteorological measurements, we placed a station in the core of the urban heat islands that we could identify via remote sensing, and we followed it with mobile measurements in some representative street of Tel Aviv. And then we calculated the urban climate effect on heat stress for human being. So a few words concerning the climate of Tel Aviv. As all we can see, Tel Aviv located at the east coast of the Mediterranean Sea. The area of the city itself is 50 square kilometers. The city is spread from north to west along 14 kilometers, and the width of the city is something between 3 to 6 kilometers. And the city is actually the core of the largest metropolitan area in Israel with almost 4 million population. The climate is subtropical Mediterranean climate, which means that the average maximum temperature at summer midday is around 30, even 31 degrees, and relative humidity is around 60 and can reach a maximum of 80% in summer, while temperature are 30, which is mean severe heat stress. So what we have done, first of all, as I said, we try to locate the urban heat island, and then after we have located the urban heat island, we perform measurements in two neighborhoods. One is Florentine neighborhood, the second Shapira neighborhood, and in each neighborhood we have made portable cross-section measurements in order to see in detail the urban heat island of Tel Aviv. And now about the method called local climate zone. So this method was firstly presented in 2012 by Stewart and Oak, which I assume that some of you are familiar about Oak. And it contains 70 different units. Some of them is the built-up area and the other is the rural area. So I will start with local climate zone, which is compact high-rise building above 10 floors. The second is LCZ2 compact mid-rise, which means between 4 to 10 floors. And LCZ3 is compact low mid-rise, which is mean 1 to 3 floors. And then look for LCZ 4, 5, and 6, which are parallel to 1, 2, and 3, but they are open, which is mean open high-rise, open mid-rise, open low-rise. We have large industrial zone. We have, of course, green area within the city. And after we can classify the special pattern of the city, we can sometimes understand the city climate. So we will start with the thermal image of the city. So the thermal image, of course, when it's the most red, is the hottest place, and one can see very interesting phenomena. The north of Tel Aviv, which is actually the areas that we are located, is relatively cool, which I mean relatively cool, I mean it's not hot like the other area, but it's quite hot. And now Florentine area and Shapira area are actually the hotspot of the city, and we can see if we try to classify it according to LCZ. So this is the north of the city, which is main LCZ 4, open mid-rise, and the core of the city is either LCZ 2 or 3, which is main quite dense area. Another image is NDVI. To the one which are not familiar with NDVI, it's index that gave us the some detail about vegetation cover. So the green area, of course, are vegetated, and again look to the dense area almost without any vegetation. Then when we look at the LCZ 2, 3, which are represent the city, we try to see some geometric and surface cover properties for the local climatic zone of Tel Aviv. So, for example, the Florentine area is covered by building something around 65%, which is mean very, very dense. For example, one can see here the structure of Florentine area, and the structure of Shapira area is less dense, is only 40% building surface fraction. And within the within the Florentine area, we have also a urban garden, which is very important for our presentation. So we enlarge the air photography of LCZ2 of Florentine area, and one can see there is hardly any vegetation in the street, narrow street, and very dense building. And that's in comparison to the north of Tel Aviv. We can see there is open space between the buildings and some green pockets in each few streets. And the Shapira area, as I said, is low, but I would like to pay your attention to something else. Most of the roofs are colored in red. And in a minute, you will see the meaning of it. So when we talk about hourly temperature in Tel Aviv, so we set up in Florentine area and in Shapira area and in the rural area south to Tel Aviv meteorological stations that can present in a very good way the urban heat island of Tel Aviv. And the urban heat island of Tel Aviv during the day can reach up to 3 degrees and at night up to 4 degrees. And the hottest place, of course, you will not be surprised, is Florentine area. This is Herzl Street, if you're familiar with Tel Aviv, and Wolfson Street, while Shapira neighborhood is less, it's less dense and less hot, and the north of Tel Aviv is relatively cool in comparison to the south of Tel Aviv. Relative humidity during the day is something around 75 and can reach even 100% during the night. And concerning the wind, it's also a very important factor because wind in Tel Aviv can ventilate the city, especially when it's come from the sea, which is relatively cool comparison to the city during the summer. So one can see in the open space, the green area, it's quite a nice breeze of 5 meters per hour, and the same thing along the coast. But at the minutes that we are penetrate into the city, then the wind is reduced dramatically. So what is the impact on heat stress? As index for heat stress, we use the PET. I don't know if you're familiar with the PET, but the PET, we talk about physiological equivalent temperature, which means that if I am at the sun exposed to the wind and to the humidity and to the radiation, the actual temperatures that I will feel if air temperature is 30, so in Tel Aviv it can be 58, for example. And then we have to classify it to level of heat stress, and one can see that in the center of Tel Aviv, half of the day, we can define it as hot and even sometimes very hot. Most of the hours, look, for example, in the city center, we have warm condition, hot, very hot, and warm condition 24 hours a day, while in other neighborhood, we will have few hours at night without heat stress. So the table can present number of hourly heat stress according to the places in neighborhood. For example, Florentine, Wolfson Street, and Herzl Street in comparison to the beach area. So one can see immediately the differences between, let's say, the coast and the center of the city. In addition, as we said, we made some portable measurements in the streets in order to compare between street orientation and the temperature inside. So we took 2 streets with north-south orientation and east-west orientation. By the way, most of the people thought that east-west orientation is better from Tel Aviv because of the breeze. But it appears that it's a big mistake because the breeze is hardly can be filled inside the city as I presented before, but west-east street is exactly in the pathway of the sun, which is mean most of the day is exposed to the sea. to the sun, while north-south street will be half of the day in the shade, which is an important factor. Another thing, as I mentioned before, was in Florentine neighborhood, we had urban gardens that we have measured. So this is the street called Chizkiyahu Street and the urban garden. And actually what we done, we walked with thermometer from place to place, 24 hours a day, and we have measured the temperature. So if we look about points in the street, one can see that the neighborhood garden can be cool up to 4 degrees during the day in Tel Aviv, which is mean garden pocket, urban park are the most cool area in the city, and actually they can prevent the urban heat island effect. Now, when we made the cross section and each line it's an hour, so one can see how the temperature reduces in the urban park, and when we leave the urban park, temperature is rising again. But this phenomena is mainly during the day, but not during the night. Then what we try to do also is to understand the structure of the city and its impact on urban heat island, and we took remote sensing measurements. The two pictures in the center are satellite pictures. Look at the Florentine area, how it's hot, and look at the second neighborhood, Shapira neighborhood, how we can identify the urban park. Temperature in the urban park, surface temperature can be 27 and, by the way, 38. It's a bare grass, which is a big mistake in Tel Aviv to have a bare grass without shading. But at the moments that we have a shade, temperature can fall down in the middle of the day to 27. Look, for example, on another phenomena, building with red roof. The red roof can reach 45 degrees. Look at the street in Tel Aviv in the middle of the day can reach 53 degrees, while the building themselves can reach 33 degrees. Another thing that we could observe is also that north-south street are cooler up to 2 degrees in comparison to west-east streets. And we, of course, look about other hotspot. For example, basketball court can reach 50 degrees if it's open to the sky. This is ordinary picture and remote sensing picture. And of course, we have to try and avoid dark surfaces because they are source of heat. And look at the effect of vegetation and trees. They can reduce dramatically temperatures. And of course, the differences between shaded grass and exposed grass, something between 24-25 degrees for the shading grass and 40 degrees for the exposed grass. So what are our main conclusions? During the daytime, the city of Tel Aviv can develop an urban heat island of 3 Celsius degrees, and at night 4 Celsius degrees. In terms of heat stress, during the daytime, the city is 11 PET warmer than the rural area, and at night it's 7 degrees warmer than the rural area. The neighborhood garden is evident only during the odd hours of the day. This reduction in PET can reach around 10 degrees, and in terms of temperature, between 3.5 to 4 degrees. And maybe some design intervention that can help Tel Aviv to address the urban warming. So for mitigation of urban heat island in the internal structure of the city plays an important role determining the UHI spatial distribution. Neighborhood gardens and trees have the most significant effect on heat mitigation that can reduce air temperature up to 3.5 degrees. Street orientation is also an important element in heat mitigation. Air temperature in north-south orientated street can be lower than up to 2 degrees in comparison to east-west orientated streets in all type of local climatic zone. And if we talk about local climatic zone, so air temperature in local climatic zone 2, the compact mid-rise, is warmer by 1.5 degrees than LCZ3, compact mid-rise, and by 2.5 degrees than LCZ5, open mid-rise, and LCZ6, open low mid-rise. Now, these conclusions are especially for Tel Aviv, and I would like to show, maybe if I have one slides to show from another presentation, because we have made the same experience in the city of Be'er Sheva, which is in the desert. And I will go to the last to the two last slides. So this is the LCZ of, sorry.
Sure.
No. Okay. This is the LCZ of Be'er Sheva, and again the red is the most dense and the area that is less dense, and immediately I will say that this is the problematic area of Be'er Sheva in terms of heat island, which means that in Be'er Sheva, for example, LCZ 1 and 2 are better than LCZ 4 and 5, which is mean in Be'er Sheva we would like the city to be compact because it's in the desert. But if we're talking about Tel Aviv must build in an open way. Thank you very much.
One or two questions?
Yes, please.
It's kind of two questions that are with a different attitude. One is when you take the heat measurements, it's interesting to see, because we have the corona and the closure, to see the dense areas with the most traffic and the most factories. I think this is Florentine again, and what you've shown that it is an effect that I don't think we know how to separate from the heat effect. And if you know the temperature, what does it really give you in time, in real time? How do you work with that in real time, beside hazard to the public? And the second question is, in your research, have you seen a difference between a neighborhood with a mature big trees than small trees that just has been planted and already declared as green open area?
Okay, I don't have answers to all the question, but I will start with the problematic problem of Tel Aviv transportation and the heat that produced by transportation, because you talked about the lockdown. So actually we didn't have a measurement then because it was a lockdown, and the measurements was based on our tools that we have to set up. But I can tell you something else. One of the reasons that I came exactly on time, I planned to be here half an hour before, but Tel Aviv is blocked. And I think that from a certain capacity, it doesn't matter anymore, because most of the time Tel Aviv is blocked. Most of the time you have heat released by cars. The second question concerning the vegetation cover. So actually, we have made another experiment, and we have measured few avenues in Tel Aviv that were covered with trees, and the other, like Chen Belvoir, which was cut by the municipality. So we could see that when the trees cover all the street, the reduction, לא, לא, כן. But I don't know what's going on here. I don't know why. No. Okay. Sorry about that. So the reduction of temperature is about 2 to 3 degrees. So I can imagine that if the vegetation is still young, so the impact is small. And when the vegetation is mature, the impact is very clear and very pronounced. But I will say that the most important factor, of course, is how to cut the trees, how to design the trees. And I don't think that we have yet the answer in the cities.
Mature, right, and
yes.
Stay longer and more effect.
Okay.
One last question, because we still have the whole day to tackle heat island effect, so...
Okay, so you talk about, as I understand, about how to design in the future. But at the moment, in existing places, what are the acts that you think we can do?
The next lecture is exactly the planner perspective.
Okay.
So
his question. If I can, more technical, since I'm passionate about climatology. What do you think about the heat island effect? About Beersheba, I think it's due to the absence of wind, so the more compact structure, maybe it's for that is better than Tel Aviv. But what do you think about, for instance, in Italy in winter, it used to be cold, and the heat island effect could help to reduce the energy for the heating. For instance, in Turin, I don't know. Maybe here in winter it's not so cold as in other parts, so it's not a positive aspect. But for instance, I don't know, in Russia, the heat island effect in winter is positive. So it's always let's say depends on the place. And about the PAT index, it takes into account both for wind temperature,
solar radiation and humidity.
So it's the most complete one.
Yes.
Okay. So about the heat island.
Okay, so about the heat island during the winter. So of course, it's a positive thing because it warmed the city. But there is another big problem. The synoptic condition that create the urban heat island, creating also enormous air pollution effect. So that's why we don't think that urban heat island, neither in winter or summer, is a positive parameter. Now, if I may answer to these guys, so in Hebrew I call it the 5 tzaddiks, okay? Which is mean vegetation, color, orientation, shading. And of course, shading, I mean artificial shading, which is means that if I will take the Florentine neighborhood, for example, which is gray and even black, and I will paint it in white, I can reduce dramatically the temperature. If we will add vegetation, of course, we will reduce the temperature. If we will create shade in the street, we can help the people which are walking in the street. So there are a lot of things to do in order to tackle the urban heat island. Okay. you